Hey guys, in this video, the brilliant Mr. B is going to take you through distance time graphs. Now this is something that you need for your maths and you need for your physics. So it's really important that you get this right because you can use it in 2 different exams. This video has 15 different examples at 3 different levels. They get harder as you go through. And you can see Mr. B work through them slowly, taking you through every single step and pointing out to you what the examiners are looking for. You can jump into this video wherever you want to, wherever you feel comfortable. You can try a couple of easy questions and skip through to the medium questions and then skip through to the hard questions at the end if that's what you want. There is no pressure on this. You can revise at your own pace. Now if you want more questions to practice, don't forget there are thousands of revision questions waiting for you on my website, and there is the free revision guide which you can download to check that you've covered everything.
First thing we need to do is be able to read off various points from the graph. So we have a look at the first graph. We have a journey that someone's making on a bicycle. Now, there's a few things to note here. So at the start, I'm going to shade this in blue. We can see this kind of flat edge. And it starts at 9 a.m. and it stops at 8:30. So when we are asked the question, what time did the bicycle leave home? A lot of students are going to write down 8 a.m. because 8 a.m. is the first thing you see on this graph. But it's not actually leaving home because you have a look at the miles column here. At 8 a.m., that corresponds to 0 miles. We move along to 8:30. That also corresponds to 0 miles. And it's only when we move past that, for example, at 9 a.m., if we have a look at where the graph is up to at 9 a.m., it's even with 10 miles. So the journey has started. So the next thing to look at is that when we have this kind of slanted upwards line, that's the actual journey. The bicycle is moving, and as time goes on, as you move to the right, time goes up from 9 a.m. to 10 a.m. Then the miles increase, starting at 0. And by the time you get to 10 a.m., we've gone up to just below 30 miles traveled. So these diagonal slanted sections are when the bike is traveling. The flat sections are when the bike is not moving. So let's read through the entire journey. We start recording at 8 a.m. and the bicycle is stationary. It's still at home, it's not moving. When we get to 8:30, the bicycle starts to move and we have that green highlighted line as the bicycle is being ridden away from home. After just under 30 miles, so let's say about 27 miles, the bike stops. And it stops from 10 a.m. till 11 a.m. So both sides of the blue highlighted line in the middle. What that represents is the bike is now stationary. So we could say we've gone to a location and we're staying there for an hour and doing something there. Or on a longer journey, it could just be a break. So, it's been a lot of effort to travel those 27 miles. So we have an hour doing nothing, and then we can travel the rest of the journey. At 11 a.m., then we have the green slanted line, a second green slanted line, and that is then where the bike is travelling again. And by the time we get to 12:30, we've travelled around about 55 miles. Finally, at the end, we've got another blue section, and that's where the bicycle stopped. We've got to the destination, we're doing whatever we're doing at the destination, and the bicycle is not moving anymore. So what you should always do with these questions is just trace through the journey first. Now, for the actual question, what time did the bicycle leave home? The bicycle leaves home at the start of the first green section, and that is at 8:30 a.m. For question 2, we have a buzz journey. Now the buzz, we start recording at 1 p.m. and the buzz is not moving. So you say it's parked up at your house, waiting for people to arrive to get on the buzz. So the buzz is stationary. Then it starts to move from 1:30 and it goes about 20 miles and stops moving at 12:30. So we can say the buzz is now at its destination and it doesn't move for another hour. So the buzz has got to the location, people have got them out, they're doing whatever they're doing at the location, sightseeing, shopping, whatever that is. Then at 3:30, it starts to move down and it's moving back towards home, moving downwards. Now, what this represents is it's not that the buzz is going backwards or anything like that. The buzz is traveling. It's traveling 20 miles. But it's going from the destination back to where it started. And so you can see the difference now between question 1 and question 2. In question 1, the bicycle travels twice. There's 2 green sections, and both times it's travelling further away from where it started. Whereas with question 2, with the bus, it's got 2 travelling sections, the green and the pink one. But the green section, it's travelling away from home 20 miles. And then the pink section, it's returning back to where it came from. So it's got a return journey. It's not 2 outward journeys. It's an outward journey, then an inward journey. Now, looking at the question, it says, what time did the bus leave home? So again, it's at the start of the green section where it leaves home. And that looks like it's 1:30 p.m. Again, it's important not to write 1 p.m. here. We start recording the movements of the bus at 1 p.m., but it doesn't move for the first half an hour. Moving on to question 3, we have a car journey, and the car will start recording at 5 p.m, but the car's not moving, and the car starts to move at 5:30, and it travels just over 20 miles. It stops moving at 6 p.m. and stays stationary for an hour. So there's been a short car journey, and then it stopped for an hour. Then the car starts again. It starts to move away. And this is now quite a long journey. And it's going from just over 20 miles to right at the end, we're going up towards 170 miles. That's a very, very long journey. It then gets to destination around 9:30, and then the car is stationary because the journey is finished and it's not used anymore. So what could be happening here? Well, the car's got a short journey. Perhaps it's journeying to someone else's house to pick some people up, and then it's going on a very long journey. So perhaps a group of people going on holiday. So the first group of people have travelled from their house to the house. The second group of people pick them up, and they've all gone together. But there could be all kinds of explanations for why you might see a journey like this. Now we have a look at the question. At what time did the car arrive at the destination? So that would be at the end of the final outward journey. And that, looking all the way down, so 9:30 p.m. Moving on to question 4, we have another car journey. It starts straight away. There's no stationary section at the start this time. It starts moving at 6 p.m. It travels for an hour to 7 p.m. It travels 70 miles. The car is then stationary for an hour. So perhaps we've driven 70 miles to a particular shop we need to get something from. And then at 8 p.m. it starts to travel back. Now, this is an inward journey. It's coming back home. The number of miles is going down. So the number of miles is going down. The car is travelling. It's travelled 70 miles, but it's travelling the opposite direction. And then when the car journey is finished, the car is stationary because it's not being used anymore. So looking at the question, what time did the car start to return home? So that's the start of the return journey. So that's the start of the pink section. So we find that, draw a line down and find the time, and that was at 8 p.m. Now for the final one, what time did the bicycle arrive home? So we have a journey, it's a bicycle journey. First thing to do is to look at what's happening. So we start recording at 12 p.m, but the bike is not in use for the first hour. The bike then takes an hour travelling 10 miles away from home. The bike stops and it's stationary for an hour, and then the bike goes back home at 3 p.m. But it takes a little bit longer to get back. It's not an hour to get back this time, it's going to take an hour and a half. So perhaps the person's tired and the journey's taking longer. At 4:30, they're back home, and it's stationary again. So we could imagine this is something like perhaps someone's taking the bike ride to the shops, they're going shopping for an hour, then they're coming back home. It's slower on the way home, so maybe they're weighed down by the shopping, and that's why it's taking longer. It's more effort to pedal. So the question was, what time did the bicycle arrive home? So that'll be at the end of the return journey. And it looks like that is at 4:30 p.m. So with the easy questions, we're reading off individual points in the journey. For the medium questions, we're now going to get into a little bit more detail in these. But we'll start off the same way. We're going to have a look at the graph and try and figure out what the journey represents. So our first journey, someone is stationary for half an hour. Then they're travelling from 8:30 to 10 a.m. and they've travelled about 95 miles. Then they're stationary for an hour, so this could be some kind of break, and they're travelling for another half an hour, and it's from about 95 miles up to 120 miles. So they've travelled around about 25 miles further, and then they stop at 11:30 and they are stationary, so they have finished the journey. So the question is, how long did the journey take? So we have to find the start of the journey. Journey started at 8:30 when the person started to move, and the journey ended at the end of the second outward travelling section at 11:30. So we're including in between those two times a outward travel section between 8:30 and 10. We have the stationary section between 10 and 11, so the breaks including the journey, and then the second outward journey between 11 a.m. and 11:30. So we need to kind of write down some working out here. So we're going from 8:30 a.m. and travelling until 11:30 a.m. So we have to work out the distance in time between those two numbers. So each count up in hours. So we'll start at 8:30. So 1 hour will be 9:30. 2 hours would be 10:30 and 3 hours would be 11:30. So our answer is 3 hours. The journey took 3 hours. For question 2, the journey starts straight away at 5 p.m. through 6 p.m. and stopping at 7 p.m. Then the bus is stationary for an hour before returning back to where it came from 8 p.m. going to 11 p.m. Now, what being asked for is how long was the bus at the destination? So the destination, if we have an outgoing journey in green and an incoming journey in pink, a return journey, then the destination must be the section in the middle where it stopped. So the stop started at 7 p.m. and it finished here at 8 p.m. So if we're at our destination from 7 p.m. to 8 p.m, it's a nice and easy question. That looks like it's exactly 1 hour. Moving on to question 3. We start recording at 3 p.m, but there's no movement for the first half an hour, so that's not included in our journey. Journey starts at 3:30 and it finishes at 5 p.m. They've travelled around about 17, 18 miles. The journey stops, nothing happens for the next hour and a half. And then there's another outward journey that takes about half an hour, and that's probably about 12 miles travelled, from about 18 up to 30 miles. So we can't just read off 30 there and say, oh, it's travelled 30 miles. That 30 is the 2 green sections combined. Then from 7 p.m. onwards, we're stationary, the journey is finished. So we're being asked, how far away from home was the destination? So destination must be the final stationary section where the journey stopped. Now, we're not looking downwards here like we have before and looking for the time. So we're at the destination at 7 p.m. But we're not being asked the time we're at the destination. We're being asked how far away from home was the destination. So how far will be a distance. So this time, I'm not looking downwards, we're going to look across. We're going to see how many miles we travelled. As we've already said, it's 30 miles away from where we started. So we can write our answer down straight away there. It was 30 miles. The journey started at 0 miles and it ended at 30 miles. Moving on to question 4, we have a bus journey. The bus is stationary for the first half an hour that we're looking at it. It then has an outward journey for an hour. It's stationary for an hour. And then there is a return journey that takes an hour and a half. And at 6 p.m, the bus is then stationary, it's finished its work for the day. Now we're being asked, what distance did the bus travel in total? So it's very similar to the previous question. So we're starting at 0 miles and it ends, the outward journey at least, at 30 miles. So we know we have 30 miles in the outward journey. Now what we can't miss out here is also a return journey, and we're starting 30 miles away from home and we're ending 0 miles away from home because we've got back to where we started. So the bus has travelled another 30 miles. Now, even though it's starting at 30 and at 0, it's not negative 30 miles. You can't have a negative distance. So even though you might be tempted to write it as a negative, we always have to write distances as a positive. So we need to add those together. So 30 miles plus another 30 miles is going to give us 60 miles. The bus has travelled 30 miles away from home to the destination, stopped for an hour, and then travelled 30 miles back to where it started from. And now looking at question 5, the journey is stationary for half an hour. Then there's a half an hour of outward travel. There's a long stationary section for 2 hours. And then rather than travel back home, we're travelling onwards again to somewhere else. And after an hour of travel, the journey's over. So this could be something like travelling half an hour away from home, doing some shopping. But then after shopping, you don't go back home, you're onwards to someone else's house that's further away from where you live. Now, we're being asked how long was the break in the middle of the journey. So the break started at the end of the first outward section at 11 a.m. and it finishes at the start of the second outward journey, which is 1 p.m. Now, using a.m. and p.m. might be a little bit confusing here because you've got to add on to 11 to get up to 1. And if you're good with time, this should be no problem to you. But if you do get a bit confused with time, you could try 24-hour clock. So 11 a.m. is 11 o'clock in 24 hours time. So anything that's AM will stay the same. But for PM, we're thinking about how many hours it is afternoon. So 1 PM is 1 hour after 12 o'clock, which would make it 13 o'clock. So in 24-hour time now, it's a little bit easier to do that addition. From 11 up to 13, we need to add on 2 hours. So how long was the break in the middle of the journey? It was 2 hours long. Now, moving on to the hard questions, we're going to start to do a bit of maths here now and try and find some more complicated things. And what we're looking for is speeds. So we've looked at times, we've looked at distances. Speed's kind of something in the middle. And you might have heard of measurements for speed, and it'd be something like you might have heard miles per hour. So in the UK, this is how we measure speed for things like cars, buses, things that travel on the road. And an alternative way of writing that is mph, miles per hour. Now, miles per hour is actually a mathematical expression that you can use. And what it means is miles divided by hours. So when you see per in something like this in a unit, it means divide. The miles are being divided by the hours. And that would work for other ways of measuring, for example, meters per second, where you have a distance, and it's being divided by the time. So that might be a useful way to write this as well. We're doing distance divided by time. So for question 1, we're being asked, what is the speed of the car for the first part of the journey? Now, I'm not going to go through the full journey anymore. We should be getting good at spotting the different parts of these graphs. So the first part of the journey is the first diagonal line here. And we can identify a few things about this. So we firstly can have a look at the time. So from 1 p.m. to 2 p.m., that is 1 hour. The second thing we can identify is how far we've travelled. Now, we started at 0 and we've ended, it's in between 40 and 60. So it'll be 50 miles. So now we've identified that, now we can find out miles per hour. So we have the miles, 50, and we have the hours, 1. So we do 50 divided by 1. And 50 divided by 1 is 50. So we're travelling 50 miles per hour. In 1 hour, we've travelled 50 miles. For question 2, we've been asked, what was the speed of the bus for the second part of the journey? So we identify the second part of the journey, highlighted in green, and we read off the 2 measurements we can take from this. So firstly, the time. Now this starts at 11:30 and it ends at 12 o'clock. So that is half of an hour, from 11:30 to 12. Alternatively, you could write 30 minutes, that'd be just as fine. But if your final answer is going to be in hours, we kind of want to measure this in hours. Then we can look at the distance. Now the start of that journey, it looks like in between 100 and 120. So that's 110. And it finishes at 120. So 110 miles up to 120 miles, that would be 10 miles travelled. A common mistake here, we're writing 120, but 120 is for both journeys altogether. And you can see the first journey from 8 a.m. to 10:30 a.m., that's travelled 110 miles already. So to get to 120, we just need 10 miles extra just for the second journey. And so now we can put those numbers into the formula miles per hour. So it's 10 miles and it's half an hour. And I think rather than write that as a fraction, let's write it as a decimal instead, because we already have a fraction with a division. So we have 10 divided by 0.5. You should also have noticed that I am writing the division sign as a slash. Now the reason for that is you sometimes see MPH written as M/H. And a slash is how you write a division on a computer keyboard. And you might have used that in things like Microsoft Excel. So keep it as a slash, just so it makes more sense with the M/H, which you might see written down. And it's all just ways to remind you of what calculation you're doing. Miles per hour is a calculation, M/H, M divided by H. So with 50 divided by 1, we were saying how many ones fit into 50, and it's 50. With 10 divided by a half, we're saying how many halves fit into 10. Now, 2 halves fit into 1 whole one, and 10's 10 whole ones. So altogether, that's going to give us 20 miles per hour. 20 halves fit into 10. That's 2 halves for each whole number we have, and we have 10 whole numbers. So 10 times 2 is what we're doing here. Now for question 3, we want the speed of a car travelling away from home. There's 2 sections of the car travels. The first one is starting at home and travelling away from home, and the second one will be travelling back home. So we want that first journey. So again, we'll read off the 2 measurements, looking down for the time. From 12 p.m. to 12:30, that's going to be half an hour again. And then look at the miles, from 0 miles up to, and at the top, it's in between 30 and 40. So let's say about 35. So from 0 to 35, that'll be 35 miles. So looking at miles per hour, M/H, that'll be M 35/H, which is 0.5. Now, the previous question, we kind of realised that 2 halves fit into a whole one. So divide by a half is the same as times by 2. So with 35 divided by a half, 2 halves will fit into each one of those 35 numbers. So 35 times 2 is 70. We're travelling at 70 miles an hour on the outward journey. Moving on to question 4, the speed of a car travelling back home. So we have the outward journey from 6:30 to 8 p.m. The return journey is from 9 p.m, travelling downwards from 95 miles all the way down to 0 miles, travelling back home, and finishing at 11 p.m. So let's read off the time. So we finish at 11 p.m. and we started at 9 p.m. So that's 2 hours. And for the distance, we start at 95 miles. It's in between 90 and 100. Must be 95. And we finish at 0. So that's going down. It's negative 95. But yeah, we can't have a negative measurement, so it'll just be a positive 95 miles. Putting that into our equation, m/h. M is 95, h is 2. So we have 95 divided by 2. So using mental arithmetic, split it into 2 parts. 90 divided by 2 is 45, remember that. And then 5 divided by 2 is 2.5. So 45 and 2.5, that'll be 47.5 miles per hour. Now moving on to the last question. It's a bit more complicated again. We're being asked what's the average speed of both journeys. So we have to look at both. Now both implies we have 2 journeys. So we have the outgoing journey and then we have the return journey. So let's work out both separately. So first, the outgoing journey starts at 9:30, ends at 10:30. That takes 1 hour. And for the distance, starts at 0, ends at 20. We've travelled 20 miles. Now the return journey goes all the way back home. So the return journey must also be 20 miles. But the time, it starts at 11:30 and it ends at 1 p.m. So from 12 till 1's an hour, and 11:30 is half an hour before that. So it's going to be 1.5 hours. So let's do the calculation for both of those. So miles per hour for the outward journey, 20 divided by 1 is 20 miles an hour. For the ingoing journey, still travel 20 miles, but this time we're dividing by 1.5, because it's 1.5 hours. So how many 1.5s fit into 20? Well, this will be an example of a calculator question, and we can do 20 divided by 1.5 on a calculator, and I'm getting 13.3 recurring. So 13.33 miles per hour. So we have the 2 journeys. We're being asked for the average. So how do you find the average? Well, you add them all up. That's 20 plus 13.3 recurring. I divide by how many? And we only have 2 journeys. So add those up. Should get you 33.3 recurring. Divide by 2. And I'm getting for the final answer 16.6 recurring miles per hour. So 16 2/3 miles per hour as a fraction.